Hello everyone, and this video is actually still over chapter 2, but I decided to give related rates its own video because it's kind of like its own deal, but it is still differentiating and it ties to implicit differentiation. So this first part is just a quick practice on how to differentiate an equation with respect to time. So what that means is how you take the derivative of a variable with respect to time means it's dt on the bottom. I promise y'all, my dog does not make a sound until I start recording these videos, and now he's whining. He's crazy. But back to what we were doing. So you take the derivative of the whole equation with respect to time, which means those variables aren't going to match. When it doesn't match on the bottom, you got to keep it. So you would write dA dt or dr dt whenever you do the derivative. So I would encourage you to pause the video and try to do the derivative with respect to time of these 5 equations. So for the first one, we take the derivative of a, which is just 1, so that becomes just dA dt, equals, you have to remember that pi is a number, so that's one variable over here, r. So we're going to take the derivative, you bring the 2 to the front, multiply it by the pi, you still have r to the power of 1, and then you have to write dr dt. So that would be the first one. Then number 2, to take the derivative of this side, it would be just dv dt. Now over here we have 2 variables, so that is where you either have to use product rule or you replace one of the variables using a proportion. If you go back and look in your chapter 2 notes, we are going to, this example down here, we're going to do that. So here we're going to use product rule. So I'm going to make a little note and say product rule or use proportion to replace variable. Okay, so if you have information about r and h, that means you have r, h, dr dt, and dht, or you're just missing one of that, then you could use product rule. But if you only have information about r, or only have information about h, then you would have to replace. But if we did product rule, I'm going to keep the pi with the r squared, and then make h its own equation. So take the original second times the derivative of the first, so that would be 2 pi r dr dt. This is getting kind of blended together. Plus, now do the opposite, the original first, so pi r squared, times the derivative of h, which would just be dh dt. Make sure you don't write the d whatever dt if you're not doing the derivative. And we can just leave it like that. Okay, number 3 is the Pythagorean theorem. So these are each its own variable, but it's also in separate terms, so we don't need product rule or anything. It would just be 2a dA dt plus 2b dB dt equals 2c dC dt. That one's straightforward. So is the next one. So this one, the derivative of a would be dA dt. The derivative of s squared would be 2s ds dt. And on this last one, if you look, we're multiplying 2 variables, so we would need product rule again. So I would make 1/2 b your first, and then your h your second. So this would become dA dt equals the original second times the derivative of the first, which would just be 1/2 dB dt, right? Plus, now switch it, the original's first times the derivative of the second, which would be dH dt. So that's just a quick review on how to differentiate with respect to time. That is technically your step 4 if it's a full-on word problem. But there are ways they could ask this skill and it not be a full-on related rate. So that skill alone is important, but now let's try to apply it to an actual problem. So what are these related rates problems? It's when you have, it's real world, it's something, some type of shape or something that's changing over time. It's either increasing or decreasing. So first it helps if you can draw a picture and you label correctly parts that are moving, and you make a list of all known and unknown rates and quantities. So you label everything you can, and then you have to pick an equation that relates to your picture, right? If it's Pythagorean theorem, you would pick this equation. If you're talking about volume, you would pick this equation. So it just, area of a circle would be this one. So you got to be able to pick the right one. And then once you pick your equation, you make sure you know all your, well, you can go ahead and differentiate. And then as you plug in, just keep in mind you should have only one unknown left. I'm going to make a note of that. Should have only one unknown, one variable. So if you have more than one, that probably means you need to go to the side and see, do you actually know that, and you just have to do some math to figure it out. And then you just solve for that variable that you're looking for. So it says note, when you're plugging in non-constant quantities before differentiating, that is a big time no-no. Okay, so if something's changing over time, you cannot plug that in until the very end. Now it is okay to plug in a constant quantity before differentiating. So if something's not changing over time, which we'll talk about what that would be in a little bit. So this first example, what I was going to say is actually for this topic, I don't have an AP practice in your packet. So there are 3 related rates we're going to do. I would encourage you to try to pause the video before every problem and try to do it on, set up what you can on your own. Do as much as you can, watch the video until you are like, oh, okay, and then pause it again. Try to do these as much as you can by yourself, and then you can watch the video, stop it, watch it until, but the goal is that you do the most you can on your own. So this first one, water runs into a conical tank at a rate of 9 feet cubed per minute. The tank stands point down and has a height of 10 feet and a base of 5 feet. How fast is the water level rising when the water is 6 feet deep? Okay, so let's kind of, and they already gave you a picture, so you don't have to draw it. Let's think about what they're giving you here. So they gave you the rate of something. So if they give you a rate or how fast, or it's talking about rate, fast, that is a D number, a derivative number. And what is that the derivative of? Well, if you look at the units, it might help. Feet cubed, cubic something is volume. That is dVdt they gave you. 9 feet cubed per minute. So you notice volume on top, feet cubed, minute on bottom is your time. So the units should match. Okay, so then it says the tank stands up and has a height of 10 and a base of 5. So the size of the tank is not changing. So we can label that. The radius is 5 feet and the height of the cone is 10 feet. How fast is the water level rising? So what we have here is we have R and we have H. And we want to know how fast is this water rising when it's 6 feet deep. So what is that asking for? How fast something is, that's a rate. You're looking for a D number. So if you're looking for how fast it's rising, that's the dH dt is what you're looking for when the water is 6 feet deep. So would that be your H or your R? That is your H. 6 feet. So that's kind of like step 2. You're just kind of organizing everything they give you and put it in the notation we're looking for. So your step 3 is you write an equation relating the rates. So you can see we're talking about volume of a cone. So the formula for volume of a cone, which I believe on your AP test, it would probably end up giving you this. The cones are all 1/3. So 1/3, and then it's pi r squared, because the base is a circle, times the height. Okay, so if we pause here before we do step 4, because we need to know, should we use product rule or should we replace a variable first? We're looking for DHDT. So if we're looking for DHDT, that can be our only unknown. Do we know DRDT? No, we don't have any information about DRDT. So you can't have two unknowns. So what that means is that we need to replace our R. We need to get rid of R because we don't have anything we know about it. So I'm going to make a note right here. You don't have to write this down on a normal problem, but just for your notes, I'm going to say you're going to use constant R and H, the one that are not changing, to set up proportion. And solve for variable we want to get rid of. Why did I put an apostrophe for want? Oh goodness, we need to go back to school. We want to get rid of. So how you set it up is you can do R over H or H over R, that part doesn't matter, but use the actual variables. And then that's going to stay proportional to this original radius and height for the whole cone. So the original R is 5 and the original height is 10. You need to make sure you put the radius number on the same level and the height number is the same level as its variable. So now we can solve this. When we cross multiply and divide, are we going to solve it for R or H? Well, we're trying to get rid of R because we're looking for DHG, so you want to keep H. So when you cross multiply, you get 10 times R equals 5 times H. And we're going to solve for R so we can get rid of it. So divide by 10. So R is equivalent to 5H over 10. You could keep it like that. I'm going to simplify it since I know I'm going to do more math with it, and it'll probably just be easier if I make that 1/2 H or H over 2. I'm going to write it as 1/2 H. But you could keep that H over 2 if you want. So now I'm going to rewrite my volume equation. But I'm going to replace my R with 1/2 H. Now be careful when you replace R. R is being squared. So you need to use parentheses. R is now going to be 1/2 H. And then you square whatever you plugged in for R. And then you have times that original H. So before we take the derivative, I would clean this up. It's going to be a lot easier. So that is, the volume is equal. So I'm going to square, the reason we need to put that in parentheses is it's squaring the 1/2 and the H. So that becomes 1/3 times pi. 1/2 squared, you square the numerator and the denominator. So 1 squared is 1, 2 squared is 4, H times H. So if we clean that up, all this is like a numerical coefficient. So I'm going to write that as one thing. So that pi is like over 1. So that would just be pi over 12 when you multiply these three together. And then H times H is H. Oh, what did I forget? That's H squared. So it should be H squared times H, which is H cubed. Okay, so now we're ready to take the derivative because we got our volume in terms of just H. And that's going to be a lot easier to work with. So I'm going to come up here. And this is step 4 if you're wondering where we are on our steps. Now we're going to differentiate with respect to time. So the derivative of v becomes dv dt. Here, you're going to bring the 3 to the front, so that becomes 3 pi over 12. When you multiply it by pi over 12. You could simplify that now if you want or later. H squared times, you always have to write dh dt. So now we're ready to substitute the known quantities and rates and you solve it. So our dv dt, if we look over here, we should have everything over here. If there's something you don't have, you need to go back and see if you can find it. So dv dt is 9. Maybe I should use a different color. 3 pi over 12. We're looking for dh dt when h is 6 squared times dH dt. Now solve that for dH dt. So that becomes, I'm going to go ahead and simplify this. 3/12 is 1/4. So pi over 4. 6 squared is 36. Now I'm going to go and multiply these together. So 36 divided by 4 is 9. So that's 9 pi times dH dt. And then divide by the 9 pi to move it over to the other side. So here the 9's would cross off, simplify to just be a 1, so but that pi is still on bottom. So that becomes 1 over pi equals dH dt. And now that's your answer, but I would go write your final answer and put your units. So from there I'm going to say dH dt equals 1 over pi. What would my units be? Well, what was the units for h? Feet. Per, what was the units for our time? Minutes. There you go. Okay, so I'm going to do the next ones in another video just to make sure it doesn't cut off. But go ahead, before you start the next video, read the back and see if you can figure out where to start.